Assalamualaikum warahmatullahi wabarakatuh. Today I will talk about the introduction. So numerical method is a crucial role to help civil engineering study to help solve complex problems that involves mathematical models and simulations. The selection of a specific method depends on the nature of the problem, the available computational resources, and also the desired accuracy of the solution. So for our method, which is the Lagrange method, it's particularly useful when dealing with optimization problems subject to constraints, and it allows engineers to find solutions that balance various design considerations. The problem statement of this study is to choose the right and appropriate type of steel that is very important in construction, especially for reinforced concrete that uses combination of steel and concrete. Any complication due to unfit and unsuitable type of steel will lead to a catastrophic failure to the structure. For a typical type of reinforced concrete, the reinforced steel is required for having 40,000 or 16,000 psi yield strength. By using Lagrange method, it is aimed to estimate the minimum tensile strength but needed to have minimum yield strength of 40,000 psi. There are three objectives of this study. The first is to estimate minimum tensile strength that can reach the minimum requirement of steel yield strength. The second is to identify the approximate method to be used. And the third is to identify accuracy of Lagrange method of this case study.
Methodology. Lagrange method is basically a method for establishing a mathematical statements approximation by using any intermediate value for the independent variable. It can be used to produce a polynomial that passes through a set of points. Lagrange interpolation also can be used to interpolate the unknown function at any point within this set.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Haikal, and as for today, I'm going to present in calculation part. So for this project, our group has chose Lagrange method in solving real life problem. And as for our project, we want to estimate the closest tensile strength that should be reached in order to have the minimum yield strength needed for reinforced concrete, or also known as RC. This is important as any complications due to the unfit and unsuitable type of steel will lead to a catastrophic failure to the structure. And for typical type of RC, the reinforced steel are required for having 40,000 and up to 60,000 psi of yield strength. And by using the Lagrange method, we want to estimate the minimum tensile strength needed to have the minimum strength of 40,000 psi. So this is the actual table of tensile strength and yield strength of steels that is available in the market. From the table, we want to estimate the value of tensile strength that can meet the requirements of 40,000 psi of yield strength. So for this case, the number of I is 7, and according to the equation, the value of I will automatically give the value of n. So from there, Pnx is equal to P7x. First thing first, we must calculate the value of L. The below one right here is one of the examples from the other 7 equations to calculate the value of L. From the previous equation, we get the value of L from L0 until L7. Then, we insert the value of L into the original equation, and from there, we replace the value of X with 40,000. Hence, we get the value of 39,903.3383. So from this value, we get to know that this is the minimum value of tensile strength needed in order to achieve the 40,000 psi of yield strength.
For discussion, the proper selection of steel is crucial in construction, especially for reinforced concrete. Using the wrong type of steel can lead to catastrophic collapse. To estimate the minimum tensile strength required, we can use Lagrange technique, which incorporates design constraints into a optimization problem. The technique provides a framework for solving such problem, but its implementation depends on specific problem and mathematical formulation. Ultimately, the Lagrange technique will help calculate the minimum tensile strength needed for specific design requirement.
As a conclusion, Using mathematical methodologies in real life brings several benefits such as clarity, precision, optimization, and science discovery. Mathematics provide a strong foundation for analyzing complicated issues, making informed decisions, and improving outcomes in a variety of fields. Full potential of mathematics can be upgraded to confront the real-life difficulties and promote societal change by combining mathematical techniques with other tools and knowledge. That's all from us. Thank you.